Alrighty then. We're going to talk about motor block calculations today. And as somebody pointed out, this is the bread and butter of being an inside electrician. This is what you do for a living. So, we're going to say that we have 4 motors we're going to install. And we need to know some information about them. First of all, we need to know the horsepower they are. And we're going to say if they're 1 horsepower, 5 horsepower, 10 horsepower, and 20 horsepower. Now, the next thing you need to know is what is the voltage, because that affects the current, the full load amperage, right? All right. So we're going to say that they are 230 volts, 3-phase. 230 volts, 3 phases. Now, so the first thing we're going to do is we're going to find the full load amperage. What does this motor pull when it's making its full load amperage? Okay. So now we need to know what is the FLA of each motor. So at 1 horsepower at 230 volts, 3-phase should pull what?
According to NEC.
Yep.
4.2 amps.
A 5 horsepower? Is that right? 15.2?
Yep.
Okay, a 10 horsepower?
28.
And a 20 horsepower.
54.
All right. Now we're going to have to write that down on the next slide because we're going to lose all that. So everybody write that down. Let me hit pause for a second. Stopping quite often, but that's okay. So now, we now know our full load ampacity. And we need to find our motor branch circuit minimum ampacity. And all we do to find that is multiply the FLA times 125%. So 4.2 times 125% is 15.2. 19 even? Okay. And 28? And 54. 67.5. All right. Now, the next thing we need to do is we need to figure out what wire we're going to use. And we can select this wire. Okay? And for deration purposes, we want to have a high temperature wire, right? So we're going to select a 90-degree wire such as THHW or THHN, one of the two. Which one is in the far right column? Go to 31016. Go to 31016. All right, so now we're going to select a wire. We're going to use THHN2, which is only a 90-degree wire. And the bad news is that our equipment is old, used equipment, and it doesn't have any terminal markings. So we're going to have to use it at the left-hand column ampacity rating. So we're going to have to go over the TW column and the UF column on the far left. And that's the ampacity we're going to have to use this wire at. So let's assume that we're going to use THHW2 or THHN2, whichever it is. And we're going to use it on the far right-hand column wire. So we now are going to select some wires. And when we do this part, we're always going to say the wire and the ampacity that's worth at that temperature rating. Okay, remember we have no terminal ratings. Okay? So that means that for this wire, for motor number 1, we can use number 14, which is good for how many amps in the far left-hand column?
15.
So we cannot use number 14 for the next one, right? 15 is too little. How many amps? What wire do we have to go up to?
12.
We have to go up to number 12, which is good for 20 amps, just enough. Now we need 35 amps in the far left-hand column, and what size wire do we have?
8.
And that's good for, and our last one was 67.5 amps.
Number 4.
We're going to go with number 4 at how many amps? 70 amps, just enough. Okay. Now, you'll notice that we now know what our minimum branch circuit ampacity is, and we know what wire and the ampacity of that wire is. And the reason we need to know that is when we go up here to the taps, we have to compare. Remember that? Okay, so now we have a handout from last week where we have on the very front page, we have motor starters, don't we? Let's get that book out. Okay, so now we're going to select from our chart, we're going to select the motor starter size. And in the first one, 1 horsepower at 230 volts is still a double zero, right? Double aught? Okay, so we have a double aught starter. Okay, cool. On the second one, I should have changed the slide a bunch of times, but that's okay. We're going to stay with the slide the whole way. So, and the second one, a 5 horsepower, 230 volts. What size starter is that?
1.
A number 1 starter. Okay, and motor number 3 is a 10 horsepower. What size starter do we need?
2.
Number 2. And a 20 horsepower going to be a number 3. So we've got a nice spread there. The next thing we would do is we would select the motor overload heaters, and to do that, we need to have the size of the starter because they're sized for the starter. We're not going to do that today. Okay, we're going to save that for another day. So now, we're going to go to the next thing up. We're going to say that all of our motor branch circuit overcurrent protection devices are dual element time delay fuses. Now, where would we find the multiplier from the full load ampacity for the full load for the dual element time delay fuse? 430/50. Go to 430/50. Does everybody got this written down? Okay, so we went to 430/50, and it says the multiplier for dual element time delay fuses is 175%. Is that correct? Okay, so we're going to go back down here and we're going to look at the FLAs. And the first one is 4.2 amps. That's our code book full load ampacity. And we used the code book ampacity for everything except the motor overload heaters. Everything except the motor overload heater. So everything on this thing we're going to select today is we're going to base it on the code book ampacity. The only thing we use the nameplate ampacity for is the motor overload heater. So 4.2 times 1.75 is what? Times 1.75.
7.35.
Okay, and 15.2 times 1.75? All right, so if we multiply each one of these full load ampacities by 175%, we get these numbers. 7.35 amps for the first motor, 26.2 amps for the second motor, 49 amps for the third motor, and 94.5 amps. And the reason we don't put that on a line is that it's just our minimum. Now, we're going to go to 240.6. Go to 240.6. We're going to find the actual fuses we're going to use because these are all three-phase, so there's 3 fuses, and each fuse disconnect, safety switch, EXO, whatever you're going to call it. All right, looking at 240.6, it starts out at 15, right?
Yes.
Now, I want you to remember that what we said the other day is the top set are circuit breakers only, or circuit breakers and fuses. But if we see the list down at the very bottom, we'll see a set that are fuses only. Okay, so the top set is circuit breakers and fuses, but the little set on the bottom, which is what, 3, 6, 10, and 601? Did I leave anything out?
No, just one.
1, 3, 6, 10, and 601. Okay, now I want you to look at that and notice that 7.3 is less than 10 amps, isn't it? Okay, and by the way, the code actually says you have to go to the next smaller breaker or fuse, but you can test to see if it will start, and if it won't start, you can go to the next size larger. So if you're ever asked, you always say, yes, I tried it, but it wouldn't start. So I went to the next fuse larger, and in this case, it's 10 amp fuse. Okay, what is our next fuse or circuit breaker that is larger than 26.2?
30.
The next one's larger than 49. The next one larger than 94.5. There's no 95 amp fuse or circuit breaker? Shocking, I tell you. Now, I believe the last 2 pages of your handout, go to the last 2 pages of your little handout, and it says the sizes of, maybe that's not in there, maybe it's the second page. Sizes of safety switches. All right. So we know that we have these fuses, and we already plugged in our fuses. We're going to have a 10 amp fuse. We're going to have a 30 amp fuse. We're going to have a 50 amp fuse, and we're going to have a 100 amp fuse. And now we need to know what size motor starter we need to have to hold these fuses, because the starter is dependent on the size. And the smallest one is a 30 amp switch. So we can put a 30 amp fuse in a 30 amp switch, but there's no 50 amp. There is a 60 amp, 30, 60, 100. So this is going to be a 60 amp switch. And there is a 100 amp switch. And so those are going to be our motor starters. I'll get a list of the starter sizes. That's really simple. Okay, now we're now looking at the next step, which is find the tap conductors. I'm not going to switch slides so I don't have to rewrite everything all over again. But we're going to go to step number 7, find the tap size conductors. Now, you got to remember that a couple slides down, we're going to find the minimum ampacity of the feeders. So we're going to do that ahead of time right now. And what is the minimum size of the feeder circuit that we could bring here? If we take the largest motor, which its full load amp is 54, we take that times 125%, which is 67.5, and then we add the other FLA. So 67.5 plus 28 plus 15.2 plus 4.2 is what?
114.9.
And that is the minimum ampacity we can have for the feeder conductors. But the code says that we should always allow for expansion. And most likely when you're doing one of these kind of projects, you might wind up adding another motor or 2, and so you're going to add between 25 and 50% at least. And you always ask, well, do you think you're going to add more stuff in here, and what would you add if you did? Always ask, what expansion might you do? Because we need to allow for that now, or it costs you a lot more later to do it. Okay, so we're not going to figure we want wires that will pull 114 amps. We want to take that, and let's say we're going to multiply that times 150%. What's 150% of that is about 60 more amps, so about 175 amps, 171 amps. So let's go find, let's go back to 3, 10, 14, 16, or 3, 10, 15, 16, and find a wire in our THHN2 in the left-hand column, since we don't have any terminal markings, that will pull 175 amps or thereabouts. And a 4-aught will pull 195 amps. And the reason we need to know that is we're going to put our wire in here. So as long as our circuit breaker is smaller than that and more than 175 amps, we could use a smaller circuit breaker, right? So let's go back to 240.6. I was afraid that was going to drop everything out again. Okay, so if we're looking at 240.6, we want one that's over 175 and under 195. What fuse or circuit breaker do we have that's in that neighborhood? 175. So we're going to say that we have a 175 amp circuit breaker in our feeder panel feeding this whole motor block. And why does that affect us? Because we need to know what size that is for the tap rule. Because remember, 12 feet, 10 feet, 12 feet, 10 feet. At 10 feet, really, that's kind of a tie. You really don't want to go all the way to 10 feet. Anything under 10 feet is at the tap rule. And now we have to look at our wire down here. So that we can compare it to the tap minimum. So if we've got 175 amps is our tap rule basis, 10% is 17.5, right? But our 1/3 of 175 is what? 59?
Well, it's 58.33. So
58.33, we're going to call that 59 amps. That's good. Now, we're going to compare that so we're going to compare that to we're going to compare our minimum, tap rule minimums to the size of the load. So our 12-foot tap rule minimum is 59 amps, right? What wire would we need for 59 amps? Three, 10, 15, 16. I'm not going to hit pause. Come on, everybody get the code book. 3, 10, 15. Far left column.
Yeah, number 4.
Number 4 for how many amps?
That's 7.
So even though we only need to pull 4.2 amps full load Ampache for this little motor here, we've got to have a 70 amp tap conductor because of the distance to the fuse disconnect from the auxiliary gutter or the taps, right? Okay, so in this case, the tap rule minimum said that we have to go to this larger wire, right? Now, what is our 17.5 amp wire? That's number 12, right?
Yeah.
So our 10-foot tap rule is going to be 12 at 20, right? Okay, so if we go to the next one, we've got number 12 already, right? So the feeder circuit and I should say the tap rule, the tap conductor and the motor branch circuit conductor are the same size. So it's okay to have number 12 at 20. Okay, now we go to the next one and we're in beyond the 10-foot tap rule, so we've got to go to 59 amps. Even though it's only a 28 amp full load Ampache and 35 amp wire is our minimum, we still have to go up to a number 4 at 70 amps because of the tap rule minimum. Everybody see that?
Yeah.
Okay, so, and the last one is back down to our 15, 20 amp tap rule minimum, 20 amp minimum tap rule minimum, right? But our load is 67.5 amps, right? So we have to use this wire right here, our number 4, because the load is bigger than the tap rule minimum. And then the next thing we might do, we won't do that today, is we might find the size of the cross-sectional area of the auxiliary gutter when we have all these wires going here. So we've got 4-aught feeders coming from the distribution panel. So we've got 3 4-aughts, plus we have 3, 6, 9 number 4s, and 3 12s. And we would find the cross-sectional area of each one of those wires, multiply it times the number of them in there, and then add that all up, and that would be the cross-sectional area of just the wire. And then we would divide that by the amount we're going to allow the auxiliary gutter to be filled, which is 20%. And then we would find that would give us the minimum cross-sectional area of the auxiliary gutter. But we're not going to do that today. All right? So I think then we're going to go back and find out the size of the conduits. How can we find the size of the conduits? Actually, when we're the same size conduits, there's actually a chart in our code book that will tell us what size conduit to use. Okay? But when it's a mixed set of conduits, or mixed set of conductors in the conduit, then we have to do a cross-sectional area and then find a conduit that will work for that. We'll do that another day. So we're going to stop here for today, and that's the first steps we're going to take in a motor block calculation.